If you want to know all about chambering reamers, this is your video. Gavin Gu here from UltimateReloader.com. We're back with Fred Zeglin. Fred, thank you for joining us.
You bet.
Fred is the reamer man. Fred runs 4D Reamer Rentals, where you can rent from perhaps the world's largest collection of reamers. Fred is also an author and works with republishing works. He's got his own works, quite a catalog of gunsmithing related materials people can read and enjoy that you've published.
Right.
So we put our heads together and we thought, you know what, the world needs a video that is going to go super in depth on basically chambering reamers for bottleneck cartridges, but we'll throw in some other anecdotes as well. So thank you for coming all the way out to Ultimate Reloader.
You bet.
And getting down and dirty with me on this. So we're going to cover all the different types of tooling. We're going to cover the chambering process, and we're going to start with a conceptual knowledge backgrounder here. So what we have here is the SAAMI diagram, a great place to start when you want to understand how ammunition relates to the chamber and what the specific chamber dimensions are that you would care about when you're looking at a rifle or a chambering job and that kind of thing.
Right. You know, the first thing I think of when I look at the SAAMI prints is that there's two on every sheet. There's the chamber and then there's the ammunition. Mm-hmm. And a lot of times I think novices, when they look at those, they don't recognize the difference between the two.
Yep.
Chamber dimensions have to be larger than the ammunition in order for the cartridge to feed and function.
Yep.
And then, you know, in the firing process, that brass expands to match the chamber and then shrinks back just enough so you can extract it. Mm-hmm. So the reason for those differences in tolerances is pretty important. So when I'm teaching somebody, I always ask them to look at those dimensions and come to an understanding that the chamber dimensions are one thing, the ammunition is another.
Absolutely.
You know, so.
Yep. And so when you're looking at the ammunition dimensions, you might be making a decision for your particular rifle around things like, well, what kind of bullet am I going to use, and what kind of free bore would I need based on that, and what are the reference points here? Even an ammunition reloader could use, for instance, the base to datum line to know where their shoulder should be, and you can use gauges and that kind of thing, and this set of, you said a lot of people only look at half the diagram. That's true of the 223 versus 556 video I put out. People say they're basically the same thing. Well, exterior dimensions of the cartridge, yes, except the corner case of tracers. But when you look at the 556 chamber compared to 223 Remington, you've got things like twice the free bore.
Right.
And that is a huge difference. So it is important to be able to look at a SAAMI diagram, look at the key dimensions. One of the things you're going to look at on the ammunition side is the case rim diameter.
Right.
Right, the case rim is going to relate to your bolt face diameter, and so on and so forth. And if you're really going to get into the weeds and do a precision rifle project, you might want to supply custom reamer geometry, which we'll get into a little bit later. But let's talk about the anatomy of the chamber, because the anatomy of the chamber obviously relates to the reamer. So what we have here is a collection of 6 Creedmoor tooling and parts. This was a Howa 1500 6 Creedmoor factory barrel that I sectioned so that you can see the chamber area. We've got Hornady factory ammunition in 6 Creedmoor. I think that's a 108 ELDM bullet on there. I've got a custom reamer that I had ground with a specific free bore, and then we've got the Go gauge for 6.5 Creedmoor, for any of the Creedmoors, actually. It's basically the shoulder area. The shoulder comes up and hits
the
shoulder. Body is undersized intentionally, and then you've got your bolt face on the other side, and you're looking at those key dimensions. So why don't we walk us through all of the different parts of the chamber and the barrel and how they relate to each other.
Okay, so you know, the nice thing about a cutaway like this is that you can see all of these various features. Obviously this long cylindrical portion is your body. You have a shoulder, the neck area, and then there's a free bore area, which is a cylindrical free bore so that you have a place for the bullet to sit. And then the tapered lead part, which is the very end of the throat. Right. And the nice thing about a finish reamer is they normally contain all of those features. So I'll occasionally get a question from people about whether they have a throat or not. A standard finish reamer always has all those features. There's no reason to separate them Now, sometimes a custom gun shop will decide they'd rather do all their throating separately, and they might have their reamer ground either with no throat or with a very minimal throat.
Yep.
And then they can do custom throating for whatever the customer
And
wants.
you can see that here on the SAMI diagram for the chamber. We've got different distances for the neck area, the free bore, and then you see the angled portion there. 1 degree 30 seconds is that, so it's a degree and a half.
Right.
And that's the angle that
taper.
is present. The taper, yeah, where the bullet is going to come forward and it's going to start to engage the rifling. It's a nice transition for that rifling to start to engage.
Right.
Let's throw this in here and we can kind of see how it all fits together.
Right. The couple of things you'll spot here, there's a little bit of a gap at the end of the chamber, right at the case mouth, and that's so that if you have brass with slightly longer neck, it'll accommodate that without creating pressure problems. You can see we have a pretty long contact area for this bullet. That's why you had the longer free bore cut. And it's nice to be able to see how that ammunition engages with the chamber and what it really looks like. As far as headspace goes, the headspace is on a datum line on the shoulder, so it's a specific point that SAMI calls out or the designer of the cartridge calls out.
Here we have 0.420 inches is where that line hits the shoulder, and it's specifying 1.900 inches to 1.910 inches. So there's a range of allowable tolerance there.
Right. So with the go gauge, it should be at the minimum dimension, right? And that's what we have here. When it engages with the chamber, the actual critical points are the shoulder diameter at that 4.20 or 0.420, and then of course the breech face, because that's what's going to set the length of that chamber for correct headspace. And sometimes people don't realize that their ammunition also has headspace. So since you're a reloader guy, you know all about that.
Yeah. So headspace is basically this reference. In other words, where does the ammunition stop when it's chambered, and then your bolt face or your breech face there in that dimension. And when you resize your brass, for precision rifle, you might say, well, I'm going to bump that shoulder back, 1/1000th and a half or 2/1000ths and a half. And if you have minimal spring back, then that would relate to how much end play there would be based on those headspace dimensions.
Right. And then I think it's fun to see how the chamber reamer itself engages with that chamber. And of course, some guys are cringing right now that we're doing this.
It's just a prop.
Right. But I mean, it's very interesting to see that the flutes only, they're engaging the full length here. A finish reamer is going to cut, like we've talked about, every facet of that chamber.
So the point to illustrate here is whatever your reamer geometry is what becomes the chamber geometry. Now that assumes that you don't have run out going on, and that's a gunsmithing consideration. But the relationship between the reamer geometry, the ammunition geometry, and the reloading geometry is something that all needs to be coordinated.
Correct.
Yeah. Okay, so that's a great anatomy lesson. Next, let's talk about the chambering process start to finish. So when we chamber a barrel, we start with what's called a barrel blank, right? That's going to be a tapered or cylindrical section of steel that has the hole pre-drilled, the rifling in place, and it's typically longer than we need it to be. So you might cut down one or both ends, and on the breech end here, where we cut the chamber, ultimately the finisher reamer is going to come in, cut the profile, exactly what we described in the anatomy lesson that we just finished, and we'll have a barrel that can be installed in the receiver, the ammunition can be chambered, and we've got this optimal package. So with that as the starting point and that as the ending point, why don't you walk us through the different ways that you can get from that starting point to the
Sure. There's for sure at least two processes. The first one would be to pre-drill the chamber in some way, whether that's with a roughing reamer, which is a smaller reamer, not quite the same size as the finish reamer. That's most common and most popular in production situations, although there's a lot of guys nowadays who like to do the roughing reamer just because it simplifies the process for them a little bit. The cost, of course, is one more reamer.
Right.
there's nothing wrong with that. It's just a question of whether you can afford that or not. So,
Yeah.
so there are guys who, as a result of that, will use just a drill bit to drill out the chamber, and then come back maybe with a boring bar to clean it up so it's concentric to the bore.
Yep.
Because that concentricity is a big part of where our accuracy comes from. So it's very important to make sure that we keep everything in alignment with the bore. So. Another popular way to do it is to use the finish reamer itself to finish the entire chamber. There's nothing wrong with that. Puts a
I
little,
did that for my first chamber.
Absolutely.
Yeah, just takes a while.
Yeah, and a lot of custom gun makers do that because they believe it gives them a better finish, and we're talking about mostly hunting type guys. I recognize that the bench rest crowd has their entire own way of doing things.
One downside with the just plunge, the finisher, is that you're going to have to stop periodically to clear your chips if you don't have pressure flush.
That's
And
correct.
The less material you're hogging out, the further you can plunge before those reamer flutes pack up.
That's absolutely true. And of course that has an effect on wear and tear.
Yep.
The advantage to using the finish reamer is that you're going to have you're going to be able to keep an eye on that finish the whole way in and make sure that you're getting the quality that you're looking for. I know people like Gordy like to go in and take measurements along the way and make sure everything's staying concentric.
Yeah.
And he does that whether he were to do it with a one piece, use just the finish reamer, or if he's doing the first method where we use some kind of a roughing reamer or a drill or whatever. I personally think that both methods are equally beneficial. The big advantage to the roughing method is time, and of course the reason that production shops use roughing reamers is simply save time, get more stuff out. It's all about cost.
So there's basically three different options. You can either send the finisher all the way in, and basically it's just going to go right into that pre-rifled barrel and cut the profile the entire distance. You can use a rougher, which is an undersized reamer with slightly different geometry, and then chase that with a finisher. Or you can remove the bulk material in some other fashion. I've heard of two ways of doing this. One is the drill bit, which I typically do, and then chase that with a boring bar to get it running true. If you have a CNC machine, you can bore with a boring bar and basically pre-cut the profile undersized, kind of like you would get with a rougher reamer. The advantage of that method with the CNC machine is because it's single point boring, you're getting a really true surface.
Okay. Right.
So why don't we next talk about the tooling? So we were just talking about roughers versus finishers in terms of the process. Now we've got some tooling. You want to work through kind of the differences here?
Sure. These first on the left these are both 7x61 Sharpen Heart, a kind of an old school cartridge. The one on the left is the rougher, and if you notice, there's very little visual difference between it and the finisher. The big difference is that it's just smaller in diameter on all of the dimensions. It also doesn't have a throat, because when you're roughing, there's no reason to be cutting the rifling away.
Exactly.
Right.
And then this has a larger flute count. Is that right? Is that a 6?
I believe this is a 4 flute,
Yep.
6 flute.
Interesting.
And of course, part of that is when you're roughing, 4 flutes is going to carry the chips away faster, gives
Yeah.
you more room for chip, so
Yep.
works better that way. And that's just optional. I mean, it depends on the reamer maker, what their choice is. You'll oftentimes see the roughing reamers with steps on them as well. Instead of being all one flute, they'll have like 3 stopping points, 2 or 3 stopping points. And what they do is instead of having the taper of the body that you normally see, they'll just be straight.
Okay.
And the reason for them being straight is it's just faster. They can take out more material more quickly.
Right.
And those steps don't matter because when the finish reamer goes in, it just cleans all that up.
You know what's interesting about that is I'm experimenting with that technique with a single point boring method. And the whole goal is if you pre-drill, you've got a cylindrical section, but you've got a tapered chamber you're going to cut. And in order to get the reamer far enough ahead, once you get to finishing, sometimes you need to do a step profile so that the pilot can engage in the rifling. You don't have it kind of wandering around.
Right.
I'm not quite there yet. I tried it and I couldn't. I need to basically make a spreadsheet calculator for what each step length and step diameter needs to be, so you don't you don't want to overcut when you're roughing, right?
Yeah, then you end up with a groove in your chamber.
Exactly,
or whatever, right?
not exactly what you want. And then we have a more modern example here of these are the 2 7 PRC reamers. I used the finisher only,
right?
But the Rifle Builders kit came with the rougher,
right,
and the finisher, and they look almost identical,
right. The big difference that I see just looking at it is there's actually, even though it looks like there's a throat, there's actually nothing being cut there.
Right.
So it's just minimum bore diameter. And if you were to measure the two of them, obviously the rougher is going to be a little smaller in diameter.
Yeah.
But all the features are there. It still has a shoulder, still has a neck. You know.
There's something else that we have going on here, and that is the different pilot types. You want to walk us through that?
Sure. There's always a big argument about what's better, solid pilot or live pilot. And live pilots are sometimes called floating pilots because they just float in the bore. But I guess I would say that the advantage to a solid pilot is that there's no tolerance stacking.
Yep.
Right? Because you don't have the difference of a pilot riding on a solid, you know, in the case of the live pilot, you have a bushing riding on a solid pilot. So there has to be a tolerance there for that to be able to move. And then there's a tolerance between the pilot itself and riding on the lands.
Right.
So you can argue that the live pilot is a little bit more of a tolerance stacking issue. But then you talk to gunsmiths who are really into it, and they have pilots in every 2/10 of a diameter.
Right.
So that they can match exactly to the bore they're working with. Because believe it or not, barrel makers don't all make the bores exactly the same size.
Right.
And
then to throw another wrench into things, guys will claim you don't need a pilot at all. You don't need anything riding on the lands.
that's really true, but the downside to that is if the reamer isn't made perfectly, if the geometry is not just right, it may wander. Or if your machine's not set up right,
exactly.
you might force it to wander.
You're not going to want to do that with a floating reamer holder per se.
No,
right?
that would definitely be a rigid setup.
So I'll be experimenting with that, and I have a perfectly lined up, perfectly rigid reamer holding situation, which is why I'm going to entertain this, working with the guys at Alpha Munitions on some experimentation there. And this is one of the bushings.
Right.
And same internal diameter, and sometimes you'll see half-thousandth increments if you get a set. Sometimes the reamer will come with what they feel like is the best.
Like a plus and a minus.
Yeah. And then, like you said, the 2/10 increment kits are used, and then those can be used on indicating rods as well, which is a nice way to get the barrel aligned in
right.
the
And like if I'm renting tools to somebody and they're using Grizzly range rods or whatever type of range rod that uses a live bushing, I tell them just take the pilot that fits your reamer, take it off, put it over on the Grizzly rod or whatever you're using, so that you're using the exact same bushing in both cases.
And it's nice to have a pusher so that you can feel those lands and you can feel the fit between your bushing and the area that matters the most, right? You get further into the barrel, sometimes the lapping process will slightly change those dimensions.
Right.
Yeah. So these are reamers with fully integrated geometry for the body, the shoulder, the neck area, and the throat. Why don't we next talk about separating those operations into different reamer tooling? Sometimes we want more control over final dimensions and more flexibility in something like cutting a different freebore length or a different neck area diameter. It could be that our customer is going to turn the necks of their brass and they want a smaller neck area. And that's where we can get into some of this separate reaming tooling. Why don't we walk through what we've got here?
Sure. So the big reamer here is chamber reamer for a 50 BMG, and this particular one doesn't have a throat on it at all. The idea being that you can come back with a throating reamer and set whatever length of throat you want. You know, maybe you're going to only shoot light bullets, or maybe you're going to want to shoot just the heavy stuff.
Yep.
So you get to pick what you want.
Oh, and this is that separate throater reamer here. So they kind of go together as a pair.
Right. And you know, the big advantage is that control, the ability to set whatever length you want. It's not like you're going to revolutionize the gun world by doing a different throat length, but it allows you to have the setup you want for the ammunition you're going to load.
Yep.
And then there's also neck and throat reamers, which combine those two. So, you know, you might have a body reamer where it's cutting only the chamber, body, and shoulder. Or you might use a smaller caliber one to create your body, and then you want to come back with a neck and throat to make it for a larger diameter caliber.
Yeah, like you could, for instance, take a 22 Creedmoor reamer, and then you could come back and make it a 6 or a 6.5 intentionally, with the neck and throat reamer.
Right. Yeah. And the advantage to that might be maybe, like you said, you want to do turned necks. So you could order special reamers in neck and throat diameters to whatever dimensions you wanted.
Yep.
So those could be ways to have specialty stuff for your customers, but maybe not have to have a complete reamer made.
Yep.
And the value in that, of course, is there's guys who want to shoot one, maybe a burger bullet with a certain length, and then the next guy wants some other brand with a different length. So,
Right.
so you could have that tooling preset. Or if you're doing it for yourself, you just order what you need for your specific job.
Yep.
Right.
Absolutely. So another variable to look at is flute count and flute profile, which we've got some examples of here.
Right. First thing is how many flutes, right? So, like we talked about before, roughing reamers oftentimes come with less flutes. 4 flutes is pretty common. You'll also see that on rimfire reamers and 17 caliber, stuff like that.
Yep.
Because it allows for a little bit more chip evacuation. You don't have to pack as much that way. And then 6 flute is pretty common on finish reamers.
Yep.
There's also 5 flute reamers, and I know Gordy kind of made that popular because he was using those for 5R rifling. And I'd be curious to ask him now if he still thinks that works better or if the 6 flutes work better.
Well, I believe in a discussion with Treble, who made the 50 BMG reamers, we were just looking at, they had the opposite opinion that if you have a 5R barrel, a 6 flute reamer is going to work good with that. In terms of chatter, right? That's kind of the issue is when all of those flutes hit the rifling at the same time, does that make things kind of wobble around?
And of course, what Gordy was trying to fight was when you have an odd number of flutes engaging those rifling at the same time, it's causing some vibration and maybe pushing the reamer to one side.
Right.
So it's an interesting discussion, and the only way to solve that problem is to cut a few chambers and find out, right?
Absolutely. It'd be interesting to have a VFD on a lathe and vary the speed and just listen and feel with an indicator to see what was going on.
Right.
Yeah. A lot of different variables.
Sure.
A 5 flute reamer could inherently give you more chip evacuation than a 6.
Absolutely, because there's more room for the chips to gather.
Right.
The other thing is the difference between spiral flute and straight flute. Straight flute reamers are probably the most traditional, most commonly seen. And I suppose that comes from, early on in the gunsmithing trade, what guys would do is they would buy decimal reamers or straight reamers and regrind them, especially for small stuff.
Gotcha.
And that was commonly available. It was cheap. The spiral fluted reamers, the argument there again is to try and give you a better finish. The belief being that the spiral flute somehow is less prone towards chatter and that sort of thing. I personally have used both quite a bit, over the years, and I don't think there's a whole lot of difference. I think spiral flutes are a little slower cutting, and but the finish is just as good and the accuracy is just as good. So I don't think there's much of an argument.
Well, why don't we next look more closely at how the reamer actually cuts. So inside this tiny cylindrical area, we've got multiple cutting edges that are cleaving the metal apart into chips, right?
Right.
And the chips are rolling, and then they're coming off of the reamer flute, hitting the inner part of the chamber wall, rolling on themselves and breaking. The chip breaking is actually a really important part of this, right?
Right. Yeah, because if they stayed in one piece, they'd have to drive all the way back out the chamber. It's way better for them to break up in small pieces so that they can just slowly migrate down with the oil and everything, slowly migrate down that flute.
Yeah, and when I was machining with Bruce Tom, he does that with drilling. He'll drill a little bit and then back off, let the chips break, and then drill some more, and so on and so forth. It's almost that same principle.
Sure.
So let's talk about the cutting edge itself then.
So on finish reamers, what we see is a cutting edge that's actually almost 90 degrees to the center line of the reamer.
Okay.
And it's pretty flat. Unlike, like a drill bit has a little bit of curvature to it to help with the chip breaking and whatnot. That flat cutting edge helps break those chips very small because they don't get a chance to curl as much. And then there's 2 relief grinds off of that flat. There's what I call the primary relief grind, and I think I've heard the reamer makers call that the margin, which is a very small grind.
Like a shallow angle.
Right, and the point of that is we're in a cylinder, so you have to have relief along that curve, or you're going to drag, and you might trap a chip, or just the drag of the reamer itself will actually weld up a piece of metal and tear it out of the cylinder.
Right.
So that's not something that would be good for a chamber. We don't
Yeah.
want big grooves in our chambers, right? So that margin or that primary grind makes sure that we don't drag metal or weld.
Mm-hmm.
And then there's a secondary grind that's much steeper, and that is mainly so that the chips don't get caught, and that gives them a place to get back into the flute and travel the way they're supposed to.
Mm-hmm.
So that's the reason for those two grinds. That primary cutting edge dives in and cleaves the metal, as you say. The cutting oil is there to facilitate that, help carry the chips away, but it also protects that cutting edge from the friction. You can imagine there's an awful lot of pressure happening right there at that cutting edge.
Right.
So that helps, the oil, and that's why some guys like to think about using muzzle flush systems, is because then that aids in driving those chips out of the chamber, and they don't have to stop and clean the reamer and whatnot. Whereas, what we have to do is we have to peck. So most finished chamber reamers, you can go maybe 50 thousandths, and then you have to stop, pull it out, and clean it. And it's a good idea to clean the chamber as well, because if you happen to go back in and trap a chip on the cutting edge,
Just drag it.
yeah, it'll either damage the chamber or the reamer or both.
Right.
None of those are pretty.
Which is especially important if you have a very shallow taper case wall, because you don't have any room to spot the problem and then remove it and clean it up.
Right.
Because you're almost cutting a straight cylinder.
Right. Now, it's no big deal to do what we call a setback and rechamber, where you bump the shoulder forward, but sometimes the customer has specified maximum length on that barrel, and you want to avoid eating up any of the material for that particular
Especially
reason.
if you're at 16.1 inches, if you know what I mean. You're right on the verge of being an SBR, right? You don't want that 15.9er.
And that's that's the country sheriff's rule. When you're going to do a short barrel, you don't cut the muzzle off until you're done with the breech.
Right. Yeah. No, that makes total sense. Another thing that you mentioned previously was where the cutting edge is with respect to the center line. So a lot of them are below the center.
Yeah,
is that what you're saying?
Well, they're not aligned directly on it. I've seen them made both above and below. Like when I make single flute reamers, and we'll look at one of those before we're all done, I make those just slightly above center line. If you go too far, you can go below center line, but if you go too far below, it wants to cut oversize. It causes it to spring and grab.
Gotcha.
So, but the reason that the cutting edges or the flutes are off center is that helps with cutting, but it also helps prevent chatter. And the other thing is, we all think of the reamer as perfect. The reamer makers absolutely allow the flutes to vary just slightly, and that's to prevent chatter as well. If everything was perfectly symmetrical, that promotes harmonics and causes problems.
Yeah, like if you had 6 lands and grooves and you had 6 flutes and they're all hitting at the same time or whatever.
Better to have them engaged just slightly differently.
So that's the cutting edge. Next, let's talk about materials and coatings. So most folks are probably familiar with high-speed steel reamers, right?
Sure.
That's going to be kind of your mainstay. But we've also got carbide.
Right. Carbide is very popular in production situations. If you're making hundreds and hundreds of the same barrel, then carbide's the way to go, because its longevity is much better. It can be used in CNC because you can run it at higher speeds. It has some real advantages in that regard. For the average gunsmith, if it's a chamber reamer you're going to use a lot, it would pay for itself. If it's a one-off, it probably would not pay for itself.
Right.
In the rental situation, I don't stock carbide because it's so easy to chip. If you bump it on the lathe or into another tool or something, you could easily take a chip out of a flute. It doesn't take very much because it's much harder, much harder than high-speed steel.
Yes, exactly.
But that's one of its advantages when you're working with a barrel that's harder than average. If it's been chrome coated or chrome washed inside, then those are absolutely essential. You can't cut through chrome wash with high-speed steel.
Yeah, we've got a couple carbide reamers here. This is an Alpha Legacy, happens to be a 22 GT.
Okay.
That was from one of my builds. And then what is this guy here?
This is a 762 by 54, and I ended up with it just kind of by accident, but good life. I mean, I've used it a number of times. It's gone out on several rentals. I don't normally rent them, but I have a couple of friends that'll call up and say, I need something.
Oh, gotcha.
And I'll say, oh, I got something I can send.
Was that for Mosin Nagant builds and the like.
Yeah, exactly. I
Nice.
mean, that's that cartridge, right?
Very cool. And then some high-speed steels. These are a little bit different. You know, we've already covered the live pilot versus the solid pilot. And
Right.
The appearance is a little bit different.
And the appearance is really unrelated to the function. You know, Climber for a long time has used this kind of matte finish, kind of their signature, and I guess they maybe have kind of gotten away from that a little bit. The more recent stuff I've received from them is more polished, like what we're used to seeing from West Coast.
Yeah.
And so, like I say, the finish doesn't really affect how the tool performs. It's just a marketing or a chosen system for their manufacturing process.
Right.
But the high-speed steel works great for most situations. You know, most barrels are in the mid-30s on the Rockwell scale, and high-speed steel works great with that.
Yeah.
In fact, you know, it feels really easy to cut. I'm sure, you know, when you've done chambering, you can just sense that when you're working the tailstock. It's just easy.
Sometimes you can't even feel it.
Right.
Right. Yeah.
Yep. And so high-speed steel works great for almost all standard situations. If you're working, like we said, with chrome wash, it's not going to work. And if the barrel is above like 40 Rockwell, you're probably going to have trouble.
Right.
It's you know, what I see usually is pistols. A lot of semi-auto pistol barrels are harder than average because they have locking lugs and stuff built into them.
Right.
So that can be a problem with high-speed steel. And then, of course, if you run high-speed steel too fast, you can burn it up real quick. Whereas you're a little more forgiving with the carbide. You can probably run it a little faster and it won't heat up the same way and have problems the same way that high-speed steel does.
Makes sense. You know, and here we've been so far concentrated on standard bottleneck cartridges. Next, let's talk about some special cases. So here we have reamers with what I would call specialty applications. Let's talk about these.
Okay. So basically you get rimmed and belted, standard rimless, and we're just trying to show the different features. A rimmed reamer is going to have the actual rim cutter on it. And while you can do that separately, you could either bore it in the lathe or you can have a rim cutter made where it's just a rim cutter. Most people, for cost effectiveness and for alignment and making sure everything is proper, you just do a chamber reamer that has all those features on it.
Yeah, makes sense.
So, and of course on a rimmed or a belted cartridge, the headspace is controlled by that feature. So, you know, rim thickness sets the headspace for a rimmed cartridge, and belt to bolt face sets it on a belted cartridge.
You're hitting the rim, not the shoulder,
right,
to stop the cartridge moving forward.
Right.
Yeah.
And I think you'd like to say that you do the magic later, right? You use your reloading processes to touch on the shoulder if that's what you want to do.
Exactly. Where it can touch both, essentially.
Right.
Yep.
And there's nothing wrong with doing that. That's how you tune for accuracy and get what you want out of the cartridge.
Yeah, like a long-range 300 Win Mag comp gun or something.
Right.
Yeah.
Right. The other things we have, this is the belted one, so you can see there's a little bit of a nicking cut. And basically, you know, if you look at the geometry of the chamber, by having that little necking cut there, some guys freak out and they're like, oh, it's not cutting there, what am I going to do? The reamer is cutting full dimension, and it's in effect what it's, and it's just going to leave a small straight section right ahead of the belt. The brass isn't going to show that, you know, it's not going to be an issue. And then this one we put out kind of to demonstrate what a straight wall would look like. This happens to be for choke tooling. This is for 410 screw-in chokes. But basically, it's the same concept. It's just a straight case. It's most of the old-fashioned black powder type cartridges, that kind of thing, even 30-30, they all have like a 45-degree or a 30-degree bevel at the end of the chamber. So they don't have a free bore and throat like we're used to. And that's mostly because they were doing lead bullets, you know, turn of the century kind of stuff.
Right.
And
old school.
And even when they got to what they called copper patch bullets, the copper was pretty thin and pretty soft, so it was pretty forgiving in that regard. So I actually hear guys now, they'll come to me and they're doing a black powder cartridge and they'll want to do some throating, which is just a modern improvement on the old cartridge.
Yeah, makes sense.
So
another thing that we've got going on here is provisions for oil flow for pressure flush. And this reamer here, that's why I have this one out. If you watch my chambering video with Bruce Tom, he talks about this method, which is in order to get the oil to flow under the bushing, tightening the bushing screw in place and then notching the screw
Right.
so that it looks kind of like a star pattern. And that gives the oil a place to go under the bushing, through what looks like flutes under it,
Right.
and then all the way down. Now, there's multiple ways to do that. You've got other types of bushing
Sure.
oil allowances.
Yeah, I've seen bushings where they usually do straight cuts in the bushing, and the reason being with the rifling being curved, they want it to ride on the lands and not
Yeah.
get stuck, right?
Exactly.
Wouldn't be very good to bind up your bushing. So,
Right.
so basically that just is another way to allow oil flow from the muzzle back onto the reamer. And if you combine the two, you're going to move that much more oil and get that much more chip flow.
Yep. Awesome. Okay, so next let's talk about what you do if you want to fully customize your reamer geometry. So I think it was worthwhile to start our discussion with the SAMI diagram, because SAMI provides the specifications you're likely to use with your reamers, but what about when you want something custom or special?
Well, it's entirely up to the individual. And I think I said something before about you're not going to reinvent the world by changing the length of your free bore or something.
Right.
P.O. Ackley used to say, if you really want to change things in the industry, just raise the sights on the typewriter. You know, but the idea behind custom chamber reamers, you can order them with the geometry you want. You can get them with minimum specs. So, you know, a lot of guys will think that every reamer is made to SAMI minimum, and that's not true.
Right.
If you think about it from the manufacturer's standpoint, it's better to make it at a midpoint, so they're never too big and too open of a chamber.
Yep.
And it gives it room to be sharpened and cleaned and not go below the minimum.
Good point.
Yeah, so from a manufacturing standpoint, better to hit the middle road and make that reamer have a life.
Yeah.
Because you can send them back and have them resharpened. What I run into in the rental business is they get chip welding on them and they need to be cleaned. So what chip welding is, it's just a little bit of steel from the barrel you're working on getting actually stuck to the cutting edge. It's usually on the shoulder area or the case mouth area where there's a real sharp shoulder.
Yeah.
You know, because that's a lot of cutting force on those angles. Whereas on the body taper, you're cutting so little at a time.
Incremental, right?
Yeah, it just comes off like powder.
Yeah.
So totally different thing. But, you know, you can order neck diameter you want. You know, if you're doing stuff where you're going to be turning the necks, I get guys who say, I want a minimum no-turn neck. And basically what they're after is they don't want to have to go through the trouble of turning necks, but they'd like it a little tighter over the neck diameter.
Yep.
And that's actually a good way to do it if you don't want to do those extra steps in reloading. You can also, you know, you can modify your throat. You could have the diameter a little bit tighter, because usually standard is to go about a 1/2 thousandths over the bullet diameter. And then, of course, throat length, free bore is a big deal. And the angle of the taper, the lead, could be adjusted too if you think you've got a method that'll be better.
Yeah.
Used to be a really big deal back in the day. They would actually lap in their throat with their bullet so that they had the exact curve of the bullet. So when
Interesting.
Yeah, so when they engaged, it would all hit at the same time.
Right.
You know, and that was a solution for a day when we didn't have all the technology we have now. So.
And all of that without even talking about wildcatting, where you're going to do something kind of fundamentally off cartridge spec.
Yeah, what we're talking about when we talk about custom chamber reamers like this is working within a standard,
Right.
but making it specific to your needs.
Or like tweaks.
Right, right. And you know, I've seen reamers come to me where say they were a rimmed cartridge and somebody had reduced the rim diameter to minimum. That's okay, except then when you get some brass in that's set to maximum, now you're going to have to turn the rims of your brass just because the reamer was undersized.
Right.
So sometimes these things are, you know, somebody's idea that it's going to be better, but maybe actually creates more work for. So you made a comment at one point about maybe it's a good idea to really check the reamer when you pick it up, make sure it's exactly what you think it is.
Yep.
You know, a lot of reamers, if they have special free bore, special neck, it'll actually be marked on the back end of the reamer. So
yeah, I had these. JGS did this 6 Creed UR reamer for me, and they put 6 Creed UR on there, and then I have the reamer print over there. So at least you know there's something special. But yeah, to have the free bore value right on the reamer, I know Alpha does that. Definitely a really good thing. So having the familiarity with the the SAMI chamber specifications will help when you want to look at and modify a reamer print. And if you want to do that, let's talk about reamer manufacturers, both here in the USA and internationally. And this is a subset. This is people that we deal with directly. So in the States, you've got your major players, Manson.
Right.
Dave Manson started that.
Right. Recently sold to some new guys, and they have been awesome to work with.
Aerospace background.
Right.
Yeah.
And the thing that I think is the coolest is they redid the website. So now they have live inventory on their website. So
Right.
you can have a pretty good chance of knowing if it's in stock or not when you order. Most of the reamer manufacturers are old school guys, and they don't have live inventory on their websites.
Or even the availability to order on the
Right.
website in some
Right.
cases. Yeah. So you've got JGS Precision, Goose Bay, Oregon, Pacific Tool and Gauge, White
Right.
City, Oregon, and then Clymer.
Right.
Can't remember where he's located.
He's in Michigan.
Okay.
And Clymer is more of a standard caliber kind of place. They do mostly SAMI only. And it's interesting talking to him. He's trying to get to the point where he's got more stuff on the shelf so he can fill orders off the shelf.
Right.
But I think he's in the same situation that all the manufacturers are in. There's more demand right now than there is materials and time and tooling. So that's a hard problem for all of us.
And hopefully that improves, because as a gunsmith myself, time is money. And to have jobs held back because of the lack of the availability of reamers is a real problem. We'll get to 4D again at the end, at the end
Right.
of this video, solving some of that. And then in the non-US, so these folks are all more SAMI oriented in their work. Trebel Gun Tools over in Germany deals with a lot of European clientele, so more CIP focused.
Right.
And we showed the 50 BMG reamer that they've got, but they can also do SAMI spec work, and they have an interesting array of different types of gauges as well, including the freebore gauge that they have. So, and the picture there is of the Trebel tooling, and you'll notice the brass pilots, which are another differentiator for their tooling. Yep.
Yeah, and I think they run a longer pilot too, I believe.
Yeah, I'd have to look at that.
Yeah.
They're in millimeters and that kind of thing. So yeah.
Well, and a longer pilot, I guess, logically gives you a little bit better axial control, right? Keeps you engaged for a longer period of time. As far as brass or bronze versus steel, there are advantages and disadvantages. Brass can be impregnated with sharp objects, so they could pick up chips and, but generally speaking, the kind of scratches you would get from that are so small they wouldn't affect accuracy.
Right.
One of the problems with bore scopes is you can see way more than you need to know.
Yes.
So I occasionally hear from somebody that they got a scratch, and you see the picture and you go, well, that's such a small scratch that in reality, it doesn't affect anything.
Okay, but that's a good segue into our next topic, which is what to do when things go wrong. So nothing is more disheartening or frustrating than doing a precision rifle chamber, and all of a sudden you've got whatever the problem is. The reamer isn't cutting right, or I'm indicating on the chamber wall and it's got run out. I've got chatter. Right, run out would be more like you're going around and the indicator is swinging like that. Right, chatter would be more like that. Right, and you don't want it to get out from under you. Right, you want to. Maybe the plane is in a dive, it feels like, psychologically.
Can I pull this out in time?
Yeah, we want to pull out, we want to get things back on track. So let's talk about chatter. When do you see chatter most frequently?
It's interesting. I've seen it at every aspect of the chambering problem. If it starts early, like as soon as the shoulder engages, that's a fairly easy time to fix it, because all you have to do is slow things down and watch what you're doing, and you can probably just get rid of it with a little careful behavior.
Speed and feed kind of stuff.
Right. Slow your speed down. Adjust how much you're feeding with the tailstock. Minimize. A lot of times it's because you've been feeding too fast is why chatter happens.
Interesting. Okay.
But not always. I mean, it could be a combination of the hardness of the steel, how sticky it is, and how it's causing the reamer to flex.
Well, this is an interesting point of discussion. I think on the PTG or the JGS website looking at their recommended feed rates, it looked pretty fast, speed and feed, pretty fast RPM and pretty aggressive feed. And then when I went to Chamber Rifle, I watched Bruce Tom do his technique. He was real slow, somewhere in the 60 to 70 RPM range. He was very sparing, using pressure flush, but very sparing with the amount of feed he added each, and he would back it off, let the chips break, and then
Right.
go forward. So it's kind of like the 5 flute in a 5R versus the 6 flute in the 5R.
Right.
Different people will pick up on different things, and maybe it's the nuance of their technique that's the difference.
Could be, and of course every machine is a little different. If you have a gear drive versus a belt drive, that's going to affect chatter.
True.
So there's more considerations. A lot of people have a tendency to want to blame the tool,
Right.
and it may be the setup, it may be the steel you're
Floating
dealing
holder versus rigid reamer holder.
with. Absolutely, there's so many variables that enter into this,
Yeah.
and to automatically assume the tool is wrong is really kind of indicates that you're not thinking it through.
Right.
I believe that a good gunsmith is a problem solver.
Oh,
So
yeah.
when they see chatter, they have to say, why is this happening? If it's as simple as changing feeds and speeds, that's great.
Yeah.
Doesn't always work that way.
Right.
Sometimes the problem won't go away so simply. And when that happens, then we have tricks that we try,
One of which is, this is from the Manson website,
right?
basically to cut a slot in a patch, put the patch over the shoulder area, and then apply your
Right.
cutting oil, send it in, and the patch has a dampening or a centering kind of
Right.
effect on it, and I've seen it reduce the chatter.
Yeah, it absolutely works, and I think it's more the dampening than anything. But the fact that it's on all 4 sides or all
Yep.
around the circumference, is definitely a thing that keeps it centered, so it can't hurt.
And it might take 3 or 4 passes of another patch to work it out to the point where it's
Right.
virtually non-existent.
And you want to eliminate that chatter completely before you go with a naked reamer again.
Right.
Because if you only eliminate part of it, go back to the regular reamer without any kind of dampening, what's going to happen is that process is going to amplify itself and go back to that full chatter
Right.
again.
Yep. Kind of like the death wobble on a motorcycle. If you can slow it down initially, you're good, but it can get to the point where it gets somewhat catastrophic.
Absolutely.
Yep.
There's a couple of other ways that you can do this. The old school ways were beeswax, and basically they would pack the reamer with beeswax and allow the chips to get into that. That's great, except it's a little messy,
Right.
right? Probably the most messy way to do it is like gear grease, real heavy gear grease.
Interesting.
And it works. It does the same
Okay.
thing that the patch does. The problem is it leaves one heck of a mess.
Right.
We recently had somebody send a reamer back that was packed like that, and so we posted a picture about, maybe grease isn't the best way.
Right.
And it was fun because the guy responded to us, which we didn't really expect, and he said, "Hey, that's a great way to dampen the reamer so that you don't get chatter." And our response was, "That works great, but could you please clean the reamer when you're done?"
Exactly.
But the method that I use the most, I don't usually use the, and it's just out of habit. It's what I got used to doing.
Yep.
I take wax paper
Okay.
and I tear it in a strip about a 1/2 inch wide, and I start wrapping it up near the pilot and the throat, and wrap it kind of in a spiral pattern down the reamer. I still use oil,
Yep.
and what happens there is as you apply pressure, it cuts through that wax paper and it dampens the same way the patch does.
So you go all the way down the body? as well?
Whatever amount that I'm into the chamber.
Gotcha.
So I want to make sure there's enough paper there so that all of the flutes will be covered
Yep.
when I push it in.
And they'll cut as it engages.
Right.
Yeah.
And it's so cheap, just like the patch is cheap.
Sure. Yep.
You can use as much as you want. You're not really wasting anything.
Okay, so what about when you get a reamer that's just dull?
So a dull reamer usually is pretty obvious that it's not actually cutting. The chips don't look right. The shoulder area, usually where they're dull, is on that shoulder cut. That shoulder area is going to look chewed up. It's going to have a lot of stripes and stuff on it. It's just not going to look like a normal shoulder.
Feeding pressure, maybe?
You're going to feel a lot more pressure. When this is a little subjective, but when you're trying to describe this to somebody, when a reamer is cutting and you're turning the tailstock wheel, you can feel it engage, you can feel it suck into the material and actually pull some chips off. When it's dull, it just feels like it's grinding or sliding.
Gotcha.
You don't get that sense that it's engaging and pulling material out. So it is a little bit of touch, a little bit of experience, but I don't think it'd be hard for most guys to get it. one of the things that's interesting about that is the bigger the cartridge. So when we look at like RUMs or short action Ultramags or the WSMs, they all have these giant shoulders, 338 Lapua.
Yep.
You know, the bigger the diameter of the reamer, the more force it takes to cut because you're cutting on that whole slope.
Yep.
And one of the benefits to roughing or whichever method you use, one of the benefits is that you don't feel so much of that. So, you know, that shoulder doesn't have to engage until it gets towards the very end when you're doing the finish cut.
Yep.
So
Makes sense.
yeah, but I mean, it's not unusual to hear guys, especially novices, come back and say, you know, this reamer's dull, and you say, well, it's brand new. So it might just be the diameter of the reamer. You're not used to cutting large chambers, and a lot of times they'll admit later that that was the case.
Right. Yep. It's all about experience. So when it comes to inspecting the reamers, you know, I know a lot of gunsmiths are real particular, even using a loop or a microscope to evaluate the condition of the reamer. When you're inspecting a reamer, what are kind of the things that you're looking at?
So the first thing we look for is that the form is still all there. You know, just that it hasn't been damaged, wiped out, broken, chipped, whatever. The second thing we're looking for is chip welding, which is pretty common, really. The way to avoid chip welding is to use good cutting fluid, you know. But even with good cutting fluid, you'll occasionally get it, and it's really just a matter of the steel sticking to the reamer, and that's caused by the harder you push the reamer, the more aggressive you are with the tailstock, the more likely it is it's going to get chip weld. And you know, you asked about dull reamers. If you get a big chip weld on the shoulder, it's going to act like a dull reamer because it literally gets material built up on that shoulder angle to the point where the cutting edge is no longer available.
Right.
You know, and that'll happen with a brand new reamer. It'll happen with an old reamer. It's just a question of how hard you're pushing and whether you sense that happening. It's easy to clean off. You can take a copper penny and go along that shoulder. I usually grab it in a pair of pliers or something so I don't cut myself, you know, and I can get a good grip on it. But you can pop that chip off. You'll see a little chip welded on there. It's different color steel. It's real easy to see, and you just pop that off. The other way you can do it is you can take like a diamond lap or a stone that will fit on the inside of the flute on the flat.
Okay. Yep.
And you can actually stone that material off. You shouldn't ever stone on the periphery of a reamer because by the geometry, if you stone on the outside, you're shrinking the diameter really quickly. But if you stone on the inside flats of the flute, then that has so little effect on the actual diameter of the reamer that you're really not losing dimension. You can stone the flats a long time before you'll change the size of the reamer, as opposed to one time on the outside, you may have lost a couple thousandths on each side.
Right. Yeah, that's way too much.
Yeah.
Yeah. Well, good stuff to know about, and you know, when you take care of your tooling, it takes care of you, right? I like to think that way. If you keep it in good condition, if you use it properly, it could last hundreds of chambers.
Absolutely.
Right? And that's a lot of money making as a gunsmith with one tool.
Absolutely. Well, and I tell people, you know, there's some of the reamer makers will put a date on the shank of the reamer, and that's so that they can tell under what print was that tool made, right?
Yep.
Because the prints do change from time to time. But it's not a freshness date. The tool steel will still be tool steel 100 years from now,
right?
Assuming that you didn't get it wet and rusted, and
right.
You know, so to your point, how many chambers can you do with a reamer? You know, in a one-man shop where you're taking good care of it, using good cutting fluid, you don't drop it on something, you could get 70, 80, 100 chambers without having to send it in for a resharp.
Yeah.
And, you know, sometimes people kind of balk at that, but I have reamers that I know how many chambers they're on. And they will go for a very long time if they're cared for.
Yeah. Yeah, that's good stuff. Okay, so that's a pretty comprehensive look at reamers, and you know, hopefully this helps you guys understand what to look for in a reamer, how they work. You know, if you want to understand the relationship between the chamber and the reloading die and ammunition, how that's accomplished. That was one thing that I was going to mention that we didn't though quite yet, was when we talked about custom reamers. When it comes to having a reamer cut for a custom resizing die, there are some different formulas that you can find how to calculate how much smaller it needs to be in which directions compared to the chamber geometry. In fact, Gordy Gritters teaches that in his precision rifle building class. and he's got a diagram that he'll give you if you go to the class. So that's one other thing that you can do, and that's why a lot of these folks that make reamers also make dies. Like
Right.
Treble makes really fine reloading dies, and it's no coincidence that they make reamers, because you're really dependent on reamers for die making.
Absolutely.
And to have both of those capabilities in-house is great. And if you don't want to buy reamers, you can rent from 4D. Why don't you tell us a little bit about what you do?
So 4D Reamer Rentals is our main business is just renting headspace gauges and chamber reamers. We're getting close to 2,000 reamers in the inventory now.
That's a lot.
Yeah, it is. And it's funny because you'd think at 2,000 that you have everything. Well, we clearly don't. We keep adding as stuff comes out new. Just the other day, I noticed that we don't have the 220 Russian in our inventory. So we decided to get busy and order those because it's been around forever, but for whatever reason, we've overlooked it.
And for a lot of these reamers, you're going to need a lot of sets, like your
Yeah.
6.5 Creedmoor and your 308 Winchester and your 30-06. Yeah.
7 PRC.
Yep.
We bought a few when it first came out, and we've been buying more and more, trying to keep up.
Yeah.
You know,
It's hot.
Yeah, and it's a tricky game for a rental business. You want to buy enough to meet the demand, but if you buy too many, you end up buried in tools that aren't going to make you any money. So
Yeah. Then you should sell a bunch of those to me.
there you go. Yeah, and we do occasionally. We'll pull stuff and sell it on eBay or something. But usually we do that because they're at retirement age. You know, they're starting to have problems, a little bit of damage or something. That it's still a good reamer, still cuts a nice chamber. But if I was the guy renting it, I wouldn't like it. You know, I see that it doesn't look as pretty as it should.
Yeah. No, that
So,
makes sense.
yeah.
You got pistol reamers as well.
Absolutely.
Shotgun tooling.
Absolutely, we do.
Yeah.
Probably the most popular shotgun tooling is screw chokes. You know, and we carry several different types for rem choke, wind choke, whatever.
You got books. 4drentals.com, right? It's
Yeah.
all up there, isn't it?
Yeah.
Yeah.
So yeah, we have a store on the website that has the books and the there's some videos. We have Gordy Gritter's stuff on there, and we have the videos that I did for AGI on wildcatting and on reloading.
You've written a book with Gordy on
Yep.
chambering,
Yep.
covering two different standpoints
That's
there.
probably the most popular book in our line is the one I did with Gordy.
Nice.
And I think it's because largely of what Gordy offers, but it also covers, you know, the generic gunsmithing kind of view of building hunting rifles. So depending on what your clientele is, or if you need to know the difference between how far should I pull the stops out to do bench rest versus doing standard gunsmithing type stuff, standard factory type chambers.
Or hunting considerations
Right.
versus extreme precision.
Right.
Yeah, totally love that. Yes, so if you want to rent reamers, 4drentals.com. Fred's also got the other tooling in the books up there. And what we'd like to know from you is, did you have other questions about reamers, the types of reamers, the materials, where to acquire them? Drop a comment and we'll start a discussion. We hope that this video has been helpful to you. I know being partnered with Fred has been very helpful to me. And make sure you catch all of the follow-up stories that we're going to be publishing related to chambering rifles and other topics. Did you want to talk about the Ottelson book at all?
Sure.
Yeah.
I just recently acquired the rights to Stuart Ottison's book on the bolt action rifle. And there's actually 2 volumes. There's a second one that he did that was on different actions. The first one covers most of the popular actions that most of us would think of, Winchester, Remington, that sort of thing.
Yep.
Anyway, the reprint of the book is great because he gave me all his original artwork.
Awesome.
So not only did we reprint the book faithfully to what he originally did, but I was able to go back and take that artwork and clean it up and, you know, with modern software, bring it forward and have it be brighter, cleaner, and actually in some
I
cases
saw the
enlarge it.
side-by-side because I have the original version myself, and that's pretty much night and day.
Yeah. And part of that was to satisfy his desire to have the book look good too, you know.
Right.
Obviously, it's been a long time since it was in print, and I think to bring it back, he was hoping that it would be something that he could be proud of.
Yeah.
And of course, that matters to me too. I want him to be happy. So
Yeah, so if you want to learn about modern bolt-action rifle platforms, this book is a really great resource. That's why I bought it.
And Stuart was an engineer, so he did the whole thing from an engineer's perspective. Lots of measurements and drawings, and and information that the average person might not even think to measure for.
Right.
So if you're interested in how things work and how they're designed, that's a cool part of this book. And he goes into the points of you know, spring rate, you know, whether it's wire diameter or force or whatever. He's got lock time, and I mean, basically every single action he did all the same tests. So there's
Wow.
a summary at the end of each chapter about each action, and it covers all of these details. So let's say you wanted to design your own action. You could use this information to extrapolate what works and what doesn't work, because
Very cool.
you know from working with these different actions yourself what you like and don't like.
Absolutely.
Right. So a very cool book, and I'm really proud to be part of it. So
Yeah, I'm glad that you've, you know, restored that book and preserved it for, you know, future generations. It's
Right.
really good work.
And volume 2's coming. So
Yeah. So I'll have, if you click on that first link in the video description, information pertaining to what we shared in this video, all about all the Reamer stuff. I'll have links to some of the books as well. And again, we'd love to hear your feedback. If you have other questions for Fred, other insights that you'd like to share, drop a comment and we'll start that discussion. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. If you're interested in custom rifles like what we build here on the channel or gunsmithing services, you're going to want to go to rifles.ultimatereloader.com and get on the wait list. If you're interested in becoming a professional gunsmith, check out the Sonoran Desert Institute. They've got a degree program, they've got a certificate program, and you can study from home. Learn more at sdi.edu. Thanks again for watching.